Hello everyone, this is Kellyn Gorman. I am the Director of Technology and Advocacy at Silk, and my session for the tech calendar is on Raspberry Pi. I wanted to take some time before I went into my actual session and what that's about to discuss Raspberry Pis, the history behind them, a little bit of information about them. If you're looking to purchase one, it can be a little bit confusing because there's a lot out there with so much history with them. So I'm hoping this will be helpful. We're going to talk about, I have one of the original ones. This is a Raspberry Pi 2. I'm going to take the camera off of it, and you're going to see there's even some lovely buttons hooked to this one. How do we know this is a Raspberry Pi 2? You will find that little Raspberry Pi here and the CPU, and it will tell you this is a Raspberry 2B+. This, you may say, well, why do you still have this? This is kind of old. Most technology you find out in projects that you're doing with this kind of tech, you may not need the newest. You may not need, the most up-to-date. You don't need the max memory, the max CPU, and older ones will still work. And so I always keep these around. I never get rid of them. The biggest challenge is getting OS loaded on them. They're changing already the OS, and they're putting, let's just be honest, fancy backgrounds and everything else in the graphics, and they want to go 64-bit, and you're like, I just needed what this did. This does more than enough. So they're always getting them new and improved, but will this work for you? Absolutely. And they still sell these, which is kind of fun. When you're looking at a Raspberry Pi, what are you looking at? The actual, components in it. This is, kind of important. This is the GPIO. So input, output. This is what we use for many of our projects to interact with what we're connecting the Raspberry Pi to. We have the USB, which of course is great for, like, this has a Wi-Fi extender on it. And then our LAN. You don't use that too much anymore, do we? Yeah, we're like Wi-Fi. That's all we need. But I needed that on this one. This one did not include it, so I've got my Wi-Fi, little USB Wi-Fi on there, and HDMI, sound card connector, and like I said, I've got a button on this one. This was to activate the camera. So if somebody hit it in the project, it actually turned on the camera. We'll go on to this one here, which is my favorite overall. I'm going to take this hat off of it. This is the Raspberry Pi 3. Again, we can see what it is just by looking next to the CPU. You'll notice this one has a heatsink. This one runs a little bit hotter, so it needs a heatsink on it that was attached on it. It's very similar connectors on this one, and the GPIO. We're going to talk about this adapter in a second, but we'll go to the Pi 4. The Pi 4, you're going to see a big difference in this. Why does this look so different? Because this puppy runs really hot and it needs a big heatsink. It almost covers the GPIOs in it. I don't know if you can see it. It keeps going blurry there in that cinematic setting on my camera. Those GPIO are right here, and it's using already 2 of them. This can conflict with what you're doing with your projects, and so I wasn't as crazy about the Pi 4. It really bothered me. It also went to all micro. So if you look on this one, you can see that there's an HDMI standard on this. This has a micro HDMI, the mini HDMI, and then, no, it was micro HDMI. It's micro, I always get mixed up on those words. And then the Type-C and the USB. It may be new, but a lot of the connectors that you may already have are older, and so you have to buy all new cables too, which is kind of a pain for those of us that are working with this. I wasn't as crazy about this. I didn't need all the extra memory for the projects I was doing. It didn't give me a lot of benefit for all that it was adding to it. And why did I really not need that? Because this is what I'm after most of the time, to add this is a Pibrella, one of my favorite hats for a Raspberry Pi, as we call it. To add it onto the Raspberry Pi 4, you're going to see with this huge heatsink, I can't actually attach it. And you're going to find that with a lot of the Pi hats and the accessories for the Raspberry Pi, the heatsink may sit up so high that it affects the ability to do the projects that you're looking for, where this little heatsink here does not impact us attaching this to our GPIO. There we go. And we have connectivity. Really important. Now, what is a Pibrella? This is a hat. This gives us additional capabilities that we would have to code, we would have to build out by hand. We would have to have separate LED lights. We would have to have a breadboard. That's what these are, these GPIO entries that we can use here on this. It's got a button. You were seeing that button that I hand set up there. This one's right on the unit. This one has 3 lights, a buzzer. All that's included in the Pibrella. The Pibrella was made by Adafruit. They don't make it anymore, but let me tell you, I have grabbed a couple of these. I keep them on hand at all times. It has its own library with modules that you can import. You can use the code with Python. It's phenomenal, fantastic. It requires extra power. You can see there's a micro USB right there, but this is my favorite, absolute favorite accessory for a Raspberry Pi. Has been so for, gosh, we're probably going on 10 years now. But I use it all the time, and you'll see it in my little project that is videotaped that you'll see at the end of here that I did with the Legos and the little Christmas tree that I want to spin. It's just easy to use. I love the code that included with this, and it was just a really great product that I wish Adafruit would actually bring back. But that's the Raspberry 3. So what do you need with these? You know, we talked about the 4 and, you know, why may not need that Raspberry Pi 5. What are the differences when we start talking about what, you know, a Raspberry 3 has versus a 4? We are talking the difference between 1 gig of memory versus 4 gigs. And this can go up to 8. There was a 4 gig Raspberry Pi 4. Do you really need that? For some of the OS and the enhancements they put to the OS and the backgrounds and all the visuals and graphics and stuff, yeah, you might. But for most projects, you don't. This B3 Plus, 3B Plus, this one here, I have the latest legacy OS on it. I keep it updated regularly, and I just went up to 12.5 on the wattage for the power supply. It's fine. Works great. Does everything that I need. I have a separate power supply for this because it's power that you usually find that you need. And I just upgraded my accessories. What would I need for accessories? A mouse. Need a mouse, of course. Touch screens, they're really hard to control. I find that they don't work that well. I had one setup that worked pretty good. And the nice thing for having a touchscreen is it means less wires. So if you can get wireless ones, the 3B Plus and above, you can do with wireless, and they'll be all right. They can handle that added pressure on it, the resource usage for it. Same thing with the keyboard. Getting rid of the wires is nice, but get a full-size keyboard. Don't get, you know, they've got like these roll-up keyboards and everything else. If you're trying to coding on one of those is ridiculous. The other thing is the monitors. I see these little tiny, you know, 4-inch by 5-inch monitors. I'm getting old. I don't want to be doing that, and I don't think most kids really do either. This is a little, I think this was $50. I mean, it's an inexpensive little, you know, LCD monitor. Comes in this little organizer for it that it's a pop-up, you know, stand for it, and this works great. It's the same size as my laptop, and I can see everything. I don't, you know, it's easy to actually look at everything, and the colors are phenomenal on it. Last thing I might get, a wireless speaker. Most people have these laying around. They even give them away at a lot of events and that. Hook it up to your Raspberry Pi, and you can play music off of it. You can play the sound files, whatever you need. It's awesome. Awesome, awesome, awesome. You also need a lot of micro SD cards. I've got a little case where I keep everything in here with the adapters for it, because you usually need the adapter to a standard SD card to format them. Even on my Mac OS, I have the Pi Imager, and I will set up all of my Raspberry Pi images that I want. I'll back them up. I'll reformat all through my Mac. It makes it very easy, and then I've got them all together in one place. So these are kind of the things you need. Power supplies, cables are all standard. The less cables you can have, usually the better, because otherwise you end up with this spaghetti mess. So that's probably the biggest challenge. Motors and kits. I will have links on my blog that talk about what I think are my favorite kits for both the Raspberry Pi as well as additional kits. I will put a couple links to eBay. I would say if you want one of these Pibrellas, it's by Ada Fruit, ADAFRUIT. They make accessories for Raspberry Pi even now. Like I said, the Pibrella, like umbrella, but Pibrella, they don't make it anymore. But I still find them on eBay. So I buy them whenever I see them because I'm terrified mine are all going to go out and I'll never find them again. DC motors. DC motors are different depending on what ones you get. My trials and tribulations with this project probably came with the DC motor. Not only did I have soldering issues and had to reattach wires multiple times, you can see I've added electrical tape to this one and set it all up so it sits flat. I also had to glue a little Lego piece so my Lego would attach, because Legos don't naturally just attach to motors unless you get a Lego motor. I didn't do that. I used just a little DC motor. I don't want to pay the price for the Lego one either. And then I had to be able to attach this to my Pibrella in the GPIO in and out, so that needed to be done. This one spins very, very fast. It's hard to tell from any manufacturer how fast the rotation is on a DC motor. So knowing that different motors have different rotations on them will impact your project. You will see it impacts the project that I just worked on, and that my motor that was the right rotation speed unfortunately got destroyed. So I ended up with this one, and you'll see in the video what happened because of that. But I'll put in links that discuss the differences in the power, because you have to watch out for like the Pibrella 4s and the 5s. They have different amount of memory, so you may see a good price on a Pibrella and get one that only has 4 gigs, and you wanted the one that had 8 gigs of memory. That's important to know. It's important to know, especially if you're trying to take on a different project. If you really only need like a little bit of power, you're not using it for anything, that's more computer-wise, you're just powering a project, and it's not going to be using an interface or anything else. This is what was called a Pi Zero. You notice the pins are gone. You can solder a pin system on it, but GPIO pin. But it's now called a Pico, the new ones. This is a Pi Zero, the original ones. And this was a small, less powered unit that was used for small projects. Awesome, very tiny. You can see here's a standard Raspberry Pi versus the Pi Zero, much smaller. And came in handy for a lot of these different projects. You could still use it. Let's say we wanted to use the Pi Glow hat. I could solder the pins onto here and still use it for many projects. So if I was just doing a coded project where I needed to have it inside a unit where the lights would do a certain rotation and pattern, I could do that all in here. So very cool stuff. Same thing with breadboards. All of that stuff is still acceptable with it. You can get, I have one kit that I recommend, the Sun Founder Start Kit. There's one for Raspberry Pi, and then there's another one for Project Geek, which is more like the Arduino, which is another computer for projects and that, for small compute projects. And it's just cool stuff. It's cool stuff. Again, if, the reasoning for this is around STEM education. And if you are looking to get your kid involved in this, these are some of the best ways to do that, because the easier you make it to consume the technology, the more likely they are to learn it. And the thing that I love about it is as they learn, how to make lights light up, as they learn that when they click a button, it does something. It spins a motor, It activates a camera. All of these things, the world doesn't seem like it's such a scary place. All of a sudden, your technologists become real. They're no longer just technology consumers, they are technology creators. And this is how we create our next generation of technologists. So I am very big about believing in this technology and again, you hear about Arduino and all these other ones. I am very much about going stepping stones. I love the Raspberry Pi. This is for kids, I would say 7, 8 years old. They have to at least start reading and writing to be able to start really working with this stuff. And then, of course, they're really getting into it at 10, 12 years old, and so on and so forth. Before that, of course, you've got different, educational products that are going to be available to them that starts to get them into this idea of object-oriented languages and everything, and how do you, build out electronics and the beginnings, building that foundation. But I believe in this because it is something that I didn't have when I was a kid. I was a big Lego kid, which of course I incorporated Legos into my project that you're about to see, but I didn't have that. So the idea that this is available now and people don't take advantage of it in the day and age that we're in, especially with AI, and I feel that a lot of times this will slip back away from us because we're going into the world of low code, no code, that AI will do everything for us. If we don't understand how the world works, how are we going to bridge that world? How are we going to stay a part of that world? So hopefully this was helpful. Hopefully you will consider not just giving to the Raspberry Pi Foundation as part of the festive tech calendar. I may have gotten that backwards. But think about getting Raspberry Pis for your kids and for yourself maybe, and doing it yourself, because I won't lie to you, I love this. I still enjoy this so much. With that, Merry Christmas or Happy Holidays, and enjoy my Raspberry Pi Merry Christmas spinning Christmas tree with Legos. Thank you. Hello everyone, this is Kellyn Gorman and I am with Silk. I am doing a session, decided not to do something on my day-to-day job. What you're seeing here is a Raspberry Pi Lego Christmas tree that I have coded with Python. We'll start out with the actual physical setup. This is, of course, lovely Legos, and there's a DC motor inside there that I've built in. I had to do a little bit of adjustment on this to get it all attached because, well, I had to build my attachment and it didn't build into my components like I thought it was going to into the Lego build. There are two wires from the DC motor that hook into the Piperella here. Piperella is a hat that I really like. I just always thought this was one of the best things. It is from, who makes this? I'm trying to remember who makes this, but it's pretty cool. I'll definitely put it in my instructions so people have it if they're interested. It just makes it pretty easy to attach and code with lights and sound and everything else. And then the Raspberry Pi, this one here is a Raspberry Pi 3B+. Yeah, that's my favorite. I have 4s, I have 5s, 0s. I keep going back to the 3B+ because I just love it. It's coded with a monitor here you're seeing, of course, Linux, Debian on this, or Raspbian, as we call it on the distribution. And I have coded with this Raspberry Pi, and I'm going to show you the code on here so you can see it. I have imported in number of libraries, OS, Sys, Time, Signal, Piperella, because I am using the Piperella libraries, as well as Subprocess to play the music. And I will stretch this out so maybe you could see this a little easier with my little mouse here. But it's doing a sub-process of playing that song that I downloaded. It's just an MP3 file that's going on in the background, along with my code. And if we go down through this, you are seeing, yeah, I used Vi. I'm old school. But my function that I built for this, you're seeing me use the player, sub-process that I've got in here. And this is kind of ugly, I think, for a lot of people, that they're like, oh, why didn't you use like something like OMX player, and why didn't you do it through like maybe Pi Audio or something? No, I like having just a sub-process that I opened up a pipe and threw this in the background. And then you can see the Piperella code that we're going to pulse the lights. We're going to do time sleep and then spin the motor. And I had another motor that I liked a lot better that spun slower. So if I'm not careful, it will spin off the decorations, just letting you know. Somebody who was listening to this during a happy hour last week joked that they could hear the motor spin up in the background. So that's how fast this thing's spinning. And then it cuts it down, and then of course it shuts it off. And you can see that I've got a second process in there that I'm not actually using. Let's get back out of here. And to run this, it's pretty simple. It's just Python Christmas tree Pi. You know, this is very simple code. And what's nice about it, I think if you do this with your kids or anything, if you want to download it, it's available. The fun part of it is that you find out that your code pretty much does everything in the world. Lighting things up, spinning, you know, turning on and off engines, and I love that about it. So we're going to see if I spin everything off here. So it's going to play music, light up the lights in the Pibrella, and spin our Christmas tree. Congratulations, I destroyed the Christmas tree. But there is our project. I really wish that other motor would have survived, because you can see how fast this thing is going. I mean, it really is going fast. I pulsed the motor to try to slow it down. It's still not slow enough, and yeah, that's right, poor Christmas tree. Merry Christmas, everyone. This is Kellyn, signing off.